So I can start. Do you hear me?
We'll start at 11 o'clock.
11.
Yes, it's 11.
Oh, about 2 minutes or 3 to go.
Okay.
Yeah, I'll let you know when you can begin. But you can leave your screen shared or your
Yes.
presentation sharing.
Okay. So 2 minutes before. My name is Baba Isa Observatory, and now today I'm going to present a talk. The talk is about participative astronomy network experience in observing asteroidal occultations in Algeria.
Okay, Baba.
Yes.
Kindly,
it's a Turkish name.
Kindly repeat.
Junay. Yes.
Dunay. Okay.
D-G-O-U. Junay.
And Junay. Okay.
Yes.
Junay,
good.
Baba. Okay,
Baba
so
Isa, it means my. It's not the first name. It's the last name.
Ah, okay.
Okay.
So we'll wait a bit.
Yes.
Can somebody at the auditorium let us know when you're all back?
Yeah. Actually, I wanted to say that I don't know who is on station.
I think Charles and Jamal are there. Maybe they could let us know.
There's nobody in the room at the moment. It's just myself in the room.
Yes.
So will you give us a notification once at least we have some people in the room so we can start?
So if you see me, can you see me over here?
Yeah, I can see
Yes.
you.
This is the whole room. So if you see nobody here, then that means nobody's in the room.
It's a problem,
So
I think
the auditorium is down the road. So it will take a couple of minutes for them to come up. So yeah.
So I can wait.
Kindly.
Yes.
Thank you.
Yes. It's a pleasure. So I would like to know something. There's no person in the room, so.
The last session just ended about 15 minutes
They
ago,
take coffee.
and it was it was a coffee break, so probably they're still moving towards the room.
Okay.
Or so we'll wait a bit.
You're
Is our
from
chairperson in the Zoom?
Pardon?
Is our chairperson online with us?
Yes. The
Are you
person
the chair?
presenting. I don't hear what you say.
what did he say?
I'm asking, is our chairperson in the Zoom?
Yes, I'm the one.
Are you the chair? Okay, so then the call is yours to start or to wait.
Yeah, but at least we would need at least one physical person.
Okay.
Priscilla, one small thing. Zuhair
Yes,
is
please.
supposed to be speaking in the session, but said he can't make it. And therefore, instead of Zuhair, Benhida and Salma will be presenting jointly.
So we can give Zuhair's time to Salma?
No. So Salma has a talk by herself, but Zuhair's talk will be given by Benhida and Salma.
Oh, okay.
Yeah. Thanks.
Thanks.
Mr. Ben Khaldun will give, I think he's going to give a talk, but in science section, isn't it?
I think this is this is day 2 that you're displaying. I need to check.
I'm looking to the program.
No, she doesn't have a talk in the science session.
Okay.
Mhm.
You're interested about astronomy or teacher or your?
Myself,
Yes.
yeah, I do my research in astronomy and I also
Good.
teach.
Okay.
Yeah.
In South Africa?
No, in Uganda.
Ah, good. Very interesting. Ah, you come.
Hi, Priscilla.
Hi.
So we've got the people coming in now.
Okay.
So you should start in a minute or so.
Okay.
Yeah.
So, Junai, we shall start like in a
Yes.
minute. You can share your screen for the presentation.
Okay.
Good.
I think I have 15 minutes or less
So
than 15 minutes.
You'll have 13 minutes of presenting, 2 minutes for questions. So I'll let you know at around 10 minutes.
Okay.
Yep.
I try to finish quickly.
Yeah, so that people can interact with you.
Yes.
So welcome everybody to our session this morning. I am Priscilla Muheshi. For those who may not know me, I work here at Mbarara University of Science and Technology in Uganda, and I'm part of the outreach committee of AfAS. So I'll be chairing this session. All our presenters will be given 15 minutes in total, but actually 13 minutes will be for presentation and 2 minutes for questions. And I'll be giving a heads up at around 10 minutes such that you summarize in case you have not finished. So I welcome you all. Let's welcome Junai, who's going to be talking to us about the experience in Algeria of observing asteroidal occultation. Welcome, Junai.
Thank you very much, Priscilla. So my name is Baba Issa Junai. I'm a researcher at Algiers Observatory. And today I will present you a talk about participative astronomy network experience in observing asteroidal occultations in Algeria. So this is the outline. I will start with an introduction, definition of asteroid, definition of occultation, why study asteroids, participative astronomy occultation in Algeria, the near future prospect, and I finish with summary. So introduction, this is the Center of Research in Astronomy, Astrophysics, and Geophysics. It comes from the creation of the Algiers Observatory in 1890. 64 asteroids were discovered, including 858 on May 16th, 1916, and 859 Bouzerea on October 2nd in 1916 by the French astronomer Frédéric C. The first asteroid has the Arabic name of the city of Algiers, and the second has the Arabic name of the village where the observatory built. So today in the CRAG, we say CRAG, it means Center of Research in Astronomy, Astrophysics, and Geophysics. We are very interested to study and observe stellar occultation by asteroids, and we have obtained some positive results. So here, the instruments that we use to observe occultation, we have instruments that we can be moved throughout Algiers. We have 2 Celestron 8, 3 Celestron 11, and 1 Meade Schmidt-Cassegrain telescope, 2 inches with equatorial motorized mount. And we have also fixed instruments at Algiers Observatory, a refractor of 20 centimeter, and a Richter-Chrétien telescope of 81 centimeter. This is the picture of the telescope. We use 3 camera IOTA occultation, which contains the video camera WATEC and IOTA video time inserter version 3 and a grabber. And we wish to buy this camera. It's better. It's a CMOS camera QHIY174 GPS mono as soon as possible. So it's a photo of me working. Why asteroids? Asteroid is a small celestial body that orbits around the sun, made up of rock, metals, and ice of irregular shape, and whose dimensions vary from a few tens of meters to several hundred kilometers. There are more than 1 million asteroids listed by NASA Minor Planet Center on March 15 in 2022. Asteroids are a mine of information. They are very interesting because they are the remains of planets that didn't know form. They allow us to understand the birth of our solar system. So you can see in this picture some of these asteroids. A large portion of asteroids orbit between Mars and Jupiter, known as the main asteroid belt. Another important grouping is located beyond the orbit of the planet Neptune, the Kuiper belt. And then there is the Oort cloud, a huge reservoir of billions of comets. What's an occultation? According to Professor Bruno Siccardi from Paris Observatory, in Greek, it means an eclipse. What does it mean, eclipse? Eclipse is a projection of a shadow on a body, and occultare in Latin, it means occultation is to hide a body by another. So, for example, this is a special case of an occultation. It's a total solar eclipse, or Venus transit, or Mercury transit, or stellar occultation by the moon, or planets occultation by the moon, or transit of exoplanets. So this illustration describes this astronomical phenomenon. It's stellar occultation by asteroids. So when we have a star in infinity, we have an asteroid in front of the star, and we have the asteroid shadow path. In my field of research, I'm interested to study and observe stellar occultation by asteroids, and more specifically near-Earth objects. In this case, I trace the contours of asteroids using the occultation method. From time to time, an asteroid eclipses the light of distant star. This is a valuable event for determining the size of the small body, clarifying its orbit, or discovering satellites or rings. And the more amateurs who follow an occultation, the better. The goal: determine the shape and dimensions of asteroids. The method: measuring the precise duration of stellar occultation by an asteroid. So this illustration, we have the asteroid, it occults the star. This is an occultation. So if we have 4 observers, A, B, C, and D, you can remark that, the observer B and the observer C can observe the occultation, but the observer A and D can't. So let's imagine an asteroid of 200 kilometers in diameter that it placed 300 million kilometers from the Earth. Here it is. So observed, the A, observed by the VLT, Very Large Telescope, plus adaptive optics, resolution obtained at about 60 kilometers. B, when we use this stellar occultation by asteroid, this method with 25 observers, we can obtain this shape and have the resolution about 1 kilometers. And C, when you how can we say, a probe, a satellite, we can observe the asteroid with a resolution maybe more than 15 meters. For example, in 28, more than 24 observers, yes, they observed the shape of this asteroid named Herta. Observers follow the passage of asteroid in front of distant star, the better the determination of the shape of this small body. On July 19, 2011, this method revealed that asteroid 90 Antiope was double. We can say in this picture, each colored line corresponds here to an observer and its interruption to the duration of the eclipse caused by Antiope.
Janai, you have 3 minutes. Kindly wind up. Okay.
So I have to finish quickly. So I will not speak about IOTA, its organization, participative astronomy in Algeria. So here the first national meeting in stellar occultation by asteroids in 2016. More than 50 amateurs to try to observe occultation by the Ida asteroid. This is the second in 2017 in Bijaya. It's we 6th place to observe the occultation. There was clouds. This is the third in the south of Algeria. 7 teams. And this is the result. The observation was negative. The first observation, positive observation, it was in Algiers. Try to finish quickly. Look at this video. At 50 and 32, 50, 57, the star disappeared. The star was disappearing. And it will appear now. The star will appear. This is the result. This is the curve, the light curve. The 9th national meeting in Larouat, it's in the south of Algeria. More than 120 observers and more than 55 4 telescopes was used to observe this occultation, more than 50 teams, and this is the result. This is the path, a theoretical path, and only 2 observers observe the occultation. This is the last one in 26 February in Gardaya, more than 20 telescope and more than 40 participants. This is the telescopes. And this is the result. More than 6 positive observation. The next interesting occultation in 2020 in Algeria, there is 2. We will try to observe them. I sent a group of Algerian amateur astronomers to visually observe the stellar occultation by the asteroid 253 EMA, and they discovered that the star was double. The star was observed by Italians and Czech as well. A scientific paper was written afterwards. This is the paper. Summary, we create an Algerian amateur astronomers network to observe stellar occultation by asteroids visually to develop participative astronomy in Algeria. We hope to obtain it in the next months, more telescopes with motorized equatorial mount and CCD cameras with inserters to record the occultation and process the data to better characterize the asteroid. In collaboration with the international organization IOTA, we wish to create a relationship or share our experience with other partners around the world, and especially from Africa, in order to develop this research. Thank you for your attention.
Thank you, Junai, for your presentation.
Was that pleasure?
We've taken 2 more minutes, so we shall have quick questions. Someone in the room can help us.
Okay. I have a question. I wanted to ask, because I saw that you say that you hope to obtain a CCD camera for the observations. I wanted to ask, wouldn't it be better if you are trying to observe occultations? If you maybe
so
had,
it's a sensitive camera. It's a special camera using to observe stellar occultation. There is more than, for example, WATEC, a Japanese camera, or a camera. The name, I forget the name. It's RunCam. Yes, RunCam.
okay.
But, it's very expensive, you know. For example, WATEC, the price of WATEC is $100. For example, photonics, it's maybe $10,000.
Okay. What I was suggesting is maybe it would be better for you to use a CMOS camera instead of a CCD camera, because they are cheaper for what you get, and then also they can detect like they can capture objects in like smaller intervals, so it might be better, especially when you're checking out occultations.
The problem is to buy this camera, you know. We have problems to buy these cameras.
Okay, all right.
Yes.
It's another question.
Yes. Salam, Junai.
Hi, how are you?
Ça va?
Yes.
I have just one question, please. What about the value of seeing in your site where you observe occultation?
I think it's not. We haven't got a good saying in this, but as you can see, when we work in Algiers, but in other towns of Algeria. For example, in the south of Algeria, we have a good seeing, you know. And we
they're after
telescopes.
so every time is a different place and it has different theme, so that they cannot decide, they cannot find the theme beforehand. So they have to go to the place and check.
Yeah, how do you choose the site?
Depends on the
site.
According to the path of occultation.
Okay, I think if there's no other question, we shall move to the next presentation. Thank you, Janai.
Okay, thank you very much. It was a pleasure.
Thank you. So our next presenter is Kaola Lagon. I don't know whether that's the right pronunciation. And the person will be speaking to us about the Vasco for Kids project. So Kaola, please share your screen if you're not physically present at SAO.
Hello, everyone. Is my screen clear? Full screen.
It's blank though. I don't know whether it's for me or for everyone.
Okay, let me try again. 1 second.
I want it to be on top.
Okay, it's now clear. You have 13 minutes to present and you'll have 2 minutes for questions.
Okay, thank you. First of all,
you're welcome.
I would like to say hello to everyone and thanks for this chance to be here amongst you all. And my name is Kaola Lagon. I specialize in medicine and I'm an amateur astronomer. I'm part of the Citizen Science Project VASCO team, and I'm here to present the VASCO Kids project. So I'll be dividing my talk into 2 parts. The first one is a vision and conception about the VASCO for Kids, including an overview on children and citizen science projects in general. And the second part will be about the application, challenges and prospects of this project, how to start with kids, starting from kids to networks and collaborations. So the first part, vision and conception, let me talk a bit about Kids and Citizen Science projects. So these are 2 articles about the matter. I'm not gonna be really detailing on this, but it's just about 2 papers published by 2 researchers in the psychology of kids and science, talking about the importance of children to get their own ideas and believe in science before even adopting it as a way of thinking and as a way of developing technology. So what is VASCO? I assume that a talk by Dr. Beatrice was given yesterday about VASCO. So this is a little reminder that VASCO is a vanishing and appearing source during a century of observation, which the aim is to search for any possible extraterrestrial intelligence SETI, and throughout the process of treating those images from the Palomar telescope and the Pan-STARRS telescopes, the VASCO can reveal many astrophysical phenomena in the way of discovering cities. So this is an effective way to search for cities rather than just focusing all the efforts on having more information about cities only themselves. So let's measure together the efficiency of citizen science projects in general. Well, it's a powerful tool, but unfortunately, let's say it's not exploited or used the right way. So the main problem with citizen science projects in general is that there is a domination of the technical part on the educational and the scientific part that will be given to kids or to young people in general. So the question is why Citizen Science Project is designed in the first place. Well, yes, it's to help scientists process data, or a huge amount of data, but at the same time, when projecting these projects to the general public, including kids and young people, then the question will be more insistent on how actually to provide a suitable way to present this project and make people adopt it and believe in it, and thus working on it. So this way, we will have the Citizen Science Project here, VASCO, as a model, as a powerful tool for education for kids, because kids are difficult to manage or difficult to deal with in comparison with with adults, because they ask a lot of questions. They like to know more about all the details surrounding a topic. They are not really easily convinced, as it's thought among adults. They are not easily convinced about things they are exposed to. So this is weird, but it is absolutely a fact. So based on the experience we have in dealing with kids, we can say that transforming this tool, which is Citizen Science Project, into a powerful tool of education, can shape the vision and the imagination of the kids' mind, and also will build that relationship that we want between the kids, the children, and science, which is a trust-based relationship, which leads them to be less exposed to fake news and wrong thinking or wrong reasoning. And that is worth it because it will foster that lifelong love of science and of natural phenomena with kids, will build them a good grounding on critical thinking, as we have already mentioned, and about scientific concepts in general, especially astrophysics and astronomy, and will improve their skills, their social skills, including discussions, conversations, teamwork, etc. So let's talk now about the VASCO project and its relationship with kids. And this is the vision, building a process. We have to introduce the usage of the tools. In this case, we have a VASCO web interface. It's a web interface where working with the artificial intelligence, where the images are processed by those citizen scientists. So we are going to be familiarized with the tools, but in a creative way. We don't want to be familiarized with the tools technically only, but also scientifically. So we'll be introducing the usage of the tools. We're taking VASCO as an example, a powerful example, and then questioning the utility of these tools, and then adopting these tools at the end. So this way, the VASCO will be turned into an efficient educational method that helps students, that help pupils, and help schools at aiming or at reaching their goals of education. Sorry? Okay. So the vision of VASCO Kids passes through these 4 steps. First, we will have the observation. Kids will observe several or many phenomena, and then will set those initial ideas and their absolutely innocent thoughts about it. Let's take, for example, galaxies, black holes, 2 city and extraterrestrial creatures. And then they will go through a program that matches a lot of activities, experiments that are designed specifically for kids and absolutely framed and guided by teachers and framers. At the end, we come to here where a child will be able to understand the scientific concepts behind VASCO, as its science project. Also, we'll be able to reveal how these tools, for example, here the VASCO interface with the artificial intelligence, can lead to serve good and efficient tools for scientists to move forward in the researches. And at the end, a kid will be able to adopt the science project Vasco in this case, and we'll see it as this fitting tool and this convenient tool that can help him or help the generation or help scientists to reach their scientific goals. So at the end, following the path of scientists is the ultimate goal. Children will follow the steps of scientists in Vasco, for example, and they will go through the same general process that scientists go through while searching for SETI and extraterrestrial creatures. So this is a scientific method that is introduced to kids in a different way, in different ways. So using activities, games, experiments, simulations, imagination, questioning, even songs, all these with developing their skills, as I've already mentioned, their scientific methods, sharing ideas, building that critical and logical thinking and reasoning, etc. Let's move to the second part now, which is the application, challenges, and prospects that we aim that we want to reach. So this is a picture featuring most of the children that participate in the Vasco Kids project, and here is Professor Jamal Mimouni. Here are some of the framers, and yeah, those are the kids. So this is the first lead was with the Serious Smarties Club that was founded like in early 2000s. The aim of this Smarties Club is to encourage the spreading of science among children and youth in general. So we have three categories. The first one between 7 and 11 years old, then 12 to 15 years old, and then 16 to 18 years old, which are a bit more teenagers. And every category has a special program out of Vasco, of course, and it is based on educational pedagogy and purposes. And we picked for Vasco the second and the third categories, which is from 12 to 15 and from 16 to 18. This is the zero mission. Like as in Vasco, there is that first zero mission where it is just for testing your abilities in retrieving and processing images. So this was like replicated or let's say simulated in the real life with the zero mission. It is the zero workshop that aims at introducing Vasco project with the fun and amusing and full of interaction and imagination session. And at the end, they end up, I mean, the kids, by a mind-blown mindsets about AI, city, and Penstar oscilloscopes. These are some pictures of kids treated and discussing the results and features of Vasco. Here we have the members and framers of the Vasco team. We have about 8 experienced and science and astronomy teachers. Some are professionals, some are amateur astronomers with different specialties from astrophysics, physics to chemistry and other specialties like biology and medicine. They are committed volunteers and they work hard for free to bring science here, Vasco for kids, with a good organization, a determination, and creativity. These are some of the photos. Zainab, Mukhlis, Shaima, Iman, Mehdi, and so many others. And here you can find that they are divided into 2. We have the technical guide. Here is a picture showing Zainab processing one of the images with the kids, and the experiment help, which is the practical side of the project, of the program in general. There are absolutely tools and equipment, but we are facing some challenges in these. And these are like some featured tools like posters, infographics. We use for kids. We use supplies of experiments. So many kids, computers, of course, because we need internet network and the web interface on Vasco, handicrafts, and many other tools. What has been done until now is that we could build a good team of framers. We could actually, I have 10 minutes of extract, no? 10 seconds, I mean. I'm still having 10 seconds.
Okay.
Yes, and preparing like for the launch of related social media pages, making a good amount of content and materials, achieving that Vasco Kids program with the serious team, Smarties Club, and we have over 1,000 images treated by children only in some few weeks. These are some images from the activities we had. I can't actually comment on all of them. I would like to, but we don't have enough time. So you can see that they've gone by from defining what is the difference between primitive and developed creators, where Vasco is interested by developed city creators, to galaxies, like here, this is the game of galaxy, pizza, to drawing, do black holes experiments, to Fermi paradox, Kardashev scale, everything related to city, everything related to the multidisciplinaries that Vasco as a project offers, which is really fantastic. These are some pictures and drawings by the kids. And I think I'm not having enough time to present all of these, but these are some posters for Vasco, including the materials we use. I end up with some challenges and prospects. Technically, there are some challenges in the interface itself, but it is in the process of getting fixed, like the accuracy tool, the blink tool, and the inspecting tool, which can be modified and bettered to fit the kids themselves. We have some problems of carrying equipment, or let's say it's something that we need to improve more and more. And our main problem, or our main challenge, is the network building, because a lot of people are not interested enough, are not diffusing like what we do in the media, and we have some difficulties in getting in touch with some associations. But our prospects to have to reach that Algerian level and North African level, and then move to the Middle East and the whole African continent through AfAS, inshallah, and absolutely having a worldwide collaboration and coordination. That's it for my presentation. It was so quick. I wanted to share more, but that's what I could give. Thank you so much for you, and yeah, that's it.
To you guys.
No, it's not this guy.
Oh, thank you. Thank you, Kola, for the wonderful presentation.
You're welcome.
I think she deserves a clap.
Thank you.
We shall take from the physical attendance. Is there any question?
Any question here, guys? No, it doesn't look like locally here. You can see on the chat.
Okay. So it seems like there's no question.
Okay. I think that there is one
thank
question.
You so much.
There is one question, just
oh, yeah.
They ask about the difference between citizen science project and amateur astronomer. Well, I would say briefly that citizen science project is a full program, is a full, let's say, software in most of the cases, where people are included and involved to reach a certain purpose, while an amateur astronomer is interested in all aspects and fields of astronomy in an amateur level. That's it. Thank you.
Okay, thank you, Kola.
Kola, yes, that's correct, Kola.
So the next presenter. Okay. The next presenter should have been Zahir, but is not present, although Benida or
both Benida and Salma
would present on his behalf if I'm right. Is it true, Niruj?
Yeah.
We can't see it on Zoom. You can start now.
Okay, thank you. Let me introduce me. So I am Abdelmajid Binida. There's my colleague Selma Sila. So we replace Zuhair Ben Khaldoun for this presentation about program cooperation in Morocco, launch of a promising moment. So this representation, no, sorry. So this presentation will divide in two parts. I begin to introduce you the laboratory of amateur, and Selma will develop her cooperation with these amateurs in her field. So, as you know, amateur astronomers have always played in an important role in astronomy and astrophysics research because they have various material and time to do observation that I think that professors had not like them. So in this optic, in Morocco, we have developed some close cooperation with the Association of Amateurs in Morocco. They are living in many cities like Marrakesh, Rabat, Ifrane, Tangier. So we have they have created an association of astronomers who now work with the professional in our observatory, in Okamden Observatory. So they have created their own observatory, which called HAO for Height Atlas Observatory, and then send the code Z02 through qualification and codification by Domineur Planet. So they have in place their quality image. They can contribute closely to our research, like for example, site sighting in Aklim, or to do some exoplanet transit, or to do some photometry for variable stars and flash of impact on Jupiter that Selma will speak about it. So let me introduce you this observatory. Is very recently, this in 2021. We have beginning to construct this laboratory, this observatory. So it was inaugurated at the beginning of July 2021, and now there are 5 telescopes which are installed in this observatory, and the 6th will be done in December 22. You can show in these photos diverse telescope and variable diameter, 11 to I think 40 inch. So yeah, another photo for telescope. So the HAO observatory obtained in September 12, 2021, the Z02 code certificate. And by following the astronomy gradient relating to 6 central belt asteroid and a near Earth cruiser, NEO. Okay, so after that, they continue their work on on exoplanet transit, and here you can show some examples for a result of HAO. For example, exoplanet 10b, WASP, and 77b. You look that they make a heavy work. So plus that they take pretty image of sky by astrophotography through HAO. So let me show you some beautiful images taken by this observatory recently. And they make so usually exposition for schools and public manifestation of astronomy in Marrakesh. So there is another one. You can see that recently with the telescope in Camden Observatory. And now let my colleague Salma to tell you more about her cooperation with this laboratory. Thank you. Go on.
Thank you very much, Abdelmajid. Yes, it is my pleasure to share the work I did with the amateur astronomers. You know, Morocco is one of my host institutes to do observation. Yes, since the cooperation with amateur, I take advantage to do observation in robotic. Just what I need is to tell to the amateur astronomers the parameters of my observation, and remotely I can follow the observation. You know, for my topic, I am working on Jupiter to see meteorite impact, and since November 2021. I have the opportunity to do observation with the collaboration with the amateur astronomers. Yes, just to tell, my interest is to follow small and also the big impact on Jupiter. And I say it is a very important to do collaboration with amateur, because why it is important. Amateur can help to set up the material and can help also to do the observation, and in our part we can explain to them how we set up the parameters and how to analyze the data. Thank you. Yes, maybe I can tell the floor to my colleague.
And for the last, I'm happy to introduce you that we have a school for astrophysics in Marrakesh. It will be in July 1 to 7, 20. So I hope that our student in Africa can come in Morocco and with us in this. So the contact and and the site of this this manifestation, this school, and you can be tout enregistrement. Yeah, so is open, and you can check the site web is WASA 2022. So you are welcome, and the call is for all students in Africa. You are welcome if you are interested in spectroscopy, in astrophysics. So you got an appointment in Marrakesh in July. Thank you very much.
Thank you. If you and Benida. Any questions?
Okay.
Thank you for
Are there any questions? Okay.
Yes, there is. From here, there is.
Mm-hmm.
Okay,
Yeah.
Thank you for the beautiful talk, for introducing us to what you're doing in your beautiful, observatory. That's amazing to know that something is rising from that part of the part of Africa. I have two questions. One to Selma and then one to you, sir. So, have you started using these the data you started getting for science? If yes, can you just give us an highlight of some of the science you've done with the data from the observatory? And then the second question is about the school that you're organizing in July. Do you hope to cover to what extent are you hoping to cover for people's expenses like flight and all of those things?
Okay, yes, those data when we obtain from the collaboration are used for science. Yes, it's the data for science. And I will give more so my talk.
Oh, okay. I'm looking forward to it.
Okay. So for school, I invite you to submit your your application, and I think the SOC and log we can tell you after the response if you are. I can tell you now that all commodity it's okay. Okay, for sure. But yeah, total accommodation is okay for all student African. Okay. So now we don't have a lot to keep flight for all people. Okay. So we can. I think that we have to select some from diverse country. So I invite you to submit your application, and we can. Thank you.
All right, thanks.
Yeah, he pretty much asked the same question.
Thank you.
But thank you for the talk.
You can in the site. You can. Okay.
I will do that too. Thank you.
We have contact. Thank you.
Any questions online? I don't seem to see any. So thank you, Salma and Benida, for the presentation once again. And we shall have Salma. Salma will be talking to us about monitoring impact flashes on Jupiter with small telescopes. You're welcome. You can share your screen and begin.
Hello again, everyone. It's my pleasure to be here, and all my thanks to AfAS for this opportunity, and also all my congratulations for the nice organization. I am Salma Silambai, PhD from Senegal, and about my PhD, it is a collaboration between several institutions, Senegal, Morocco, Paris, and Belgium. Now I go to talk about one part of my topic, monitoring impact flashes on Jupiter with small telescopes. Outline of the top, introduction, context, networks, instrumentation, data analysis, and conclusion. About the introduction, I can say in the solar system, the surface of rocky planets and satellites and the atmosphere of giant planets are subject to continuous meteoritic bombardment, and knowledge of the collisional history of the small bodies is critical to understand the origin and evolution of planet. We can also know the moon is formed through impact between Earth and an object of size about Mars, and also we know the origin of water in Earth coming from an impact. And about the impact, we know we have small impact and also giant impact. The giant impact is impact caused by object more than 50 meters of diameter, and the giant impact can leave trace after the collision that we can observe few days after the impact, or few months after the impact. And for the small impact, we have not traces after the impact, and the small impact, are object up to 50 meters of diameter. Here I show some pictures like the first giant impact we observed in Jupiter in 1994, observed by the Pic du Midi Observatory. And here we see, I show you also the first small impact observed in Jupiter in 2010. And why we need to study impact on Jupiter? You know, in our solar system, we need some time to do the datation, and we know meteorite impact and the crater that create help to date the surface of rocky planets and rocky objects. However, in the outer solar system, we have not more statistics. It's the reason we need to observe Jupiter to improve the statistics in the outer solar system. My contribution of this topic is to do observation with ground telescope, and I have the opportunity to do observation in two sites, one in Africa, in Morocco, and another one in France, at the Observatory of Paris. Okay, just to tell you some words about existing network for impact flashes of Jupiter in Europe. We have the Planetary Virtual Observatory Laboratory, and through the network, an application is developed to help to find automatically a flash on observation of Jupiter. In Japan, we have also the Association of Lunar and Planetary Observers. We use a telescope of 1 meter size. Since 2010, we have found 8 small impact on Jupiter, and only 1 impact is found by the program DETECT. And what we see after the first impact detected by the program DETECT, the use of the free application is increased. And how works the DETECT? DETECT use photometry to help to find a flash on Jupiter observation. And what we do is, on the observation, on the data, we create what I can say, we create I don't know that, we create an image max and an average image. And to create the image of detection, we do just a subtraction. And now we see about more than 100 people use DETECT to analyze their data. And we, yes, and we invite people who observe Jupiter to use the application to help to improve the statistic of detection of impact flashes on Jupiter. Here I show my instrumentation. Yes, I do observation in Morocco with telescope between size of 27 centimeter and 35 centimeter. And at the Pic du Midi Observatory, we have a big telescope. I can say a big telescope compared to Morocco. Compared to Morocco setups. Yes, and after I do observation, I need to do analysis. And after the analysis of my observation, I have not yet found a flash. And what we do is now to try to collaborate more with amateur to optimize yes, to optimize our chance to find flash. And for that, I already collect data from an observer from France. We observed Jupiter since 2000, yes, since 2004, and and after the analysis, we have not yet also find impact flashes. Yes, I conclude to tell you with ground Simon telescope, we can monitor impact flashes on Jupiter thanks to high sensitivity camera. We can increase the number of detection with more temporal coverage to invite people to observe more Jupiter everywhere in the world, not only in Europe, in Africa also. And we can improve the detection to encourage the observer of Jupiter to use the DETECT application. We can help to find easily an impact. With more observation and more collaboration, we can increase the possibility to find impact flashes and to improve the flux in the outer solar system. We can extend the survey to Saturn, because our goal is to improve the statistic of impact in the outer solar system. And also, if we expand the observation in the other planets like Saturn, we can improve the detection. And also, it is possible to use data from space mission like Juno or Hubble. Yes, the announcements. Thank you for listening.
Thank you, Salma, for your presentation. We shall now take questions. Those physically present, is there any question?
Yes, indeed. I have.
Yes, please.
No, you start. You start. No, it's you start.
Okay.
Okay, indeed, thank you very much. It's a great presentation which opened up for other opportunities in the future. I was attracted to the last thing you said, Juno. The Juno, observations, are the data public? And if so, it's a great way of finding even small flashes, because of course they were very close to the thing. So are the data, the Juno data, available online, or are you want to keep it secret so you can use it for yourself for your dissertation or whatever you say? You tell us.
Yes, just what I know now with Juno, we have find an impact in 2021.
Okay.
But yes, I don't know if now the data is available for the public. Yes.
But for some scientists, you might want to get in connection directly with the team of Juno and most possibly get because it's a great thing. I mean, Juno, you are right there.
Yes.
You're not observing from the Earth or from the Pic du Midi or from Okaïde. You're right. You're observing right from where the action is. But of course, you have to be lucky to know to have a wide field enough and so on. But of course, it's not easy. Okay,
yes.
That's great.
It is one of my plans.
Okay.
All right. Wonderful presentation. My second question has been answered, obviously, by the contribution, all of that. But this first question might look naive, but I just want to understand more about what you're doing. About image detection, you wrote a small equation. Image detection is equal to image max minus image mean. What do you mean by image max? Maybe you explain a bit.
Okay. By image max, what I mean, we try to see what we have the maximum of light for the different image from our video, and what we do, and when we do this, after we take all the images from the video for do the average, the mean, yes, for do the mean, and why we do this? It is to have not a bright image, but if I can say a black image, and when you have a black image, it is more easy to see the flash because the flash is very bright. Yes.
Okay, thank you. Thank you, Salma. Maybe a question from me. I'm also green about this field, but you answered to Jamal that Juno detected one flash in 2021. Sure?
Yes. Yes, yes.
Yes, yes, yes. So, but you're showing from your observations that are ground-based that you have not detected any flash yet.
Not yet, yes.
So if there was one that could be detected by a space mission, do you think you need to change your observational strategy to improve the chances of observing impact flashes on Jupiter? Because in your conclusions, you mentioned that it's possible due to the high sensitivity of the cameras, but if there was one and you were not able to observe it on ground, then could it be a case for observational strategies or something else?
Yes, I can say we need to observe more because my observation my observation are very limited because I do only scientific visits. Yes, and when we can do to improve the possibility of detection is to expand our collaboration and to collaborate more with the other observers and to invite them to use the applications that can help to detect easily an impact.
Oh, okay. Thank you. And I also like the fact that you involve the amateur astronomers. So the amateur astronomers actually contributing to scientific astronomy. That's a very nice thing, I think. So keep it up. Otherwise, thank you all for attending our session. It was great chairing you. And I hope you're enjoying the AfAS conference. We shall be meeting later in the afternoon after the lunch break. So thank you and stay well.
Thanks.